Hello and welcome to the second OpNet tutorial at studentsplanet.net. In this tutorial, I'll show you how to configure a simple wireless LAN network using the wireless LAN station model. So let's go start a new project. I'll name the project as tutorial 2. I'll keep the scenario name as scenario 1. I'll select an empty scenario from this menu. I'll select office size network and keep the size as 100 by 100. Select one of the model families for wireless LAN so that I can see it easily in my object palette later on. And this is a summary of what I've selected so far. I'll hit the finish button. So here is my object palette. Now I'll change the view. In the previous tutorial, I think I've mentioned the difference of wireless LAN station and wireless LAN workstation. Now, if you click on it, you will find it quite a simple model. In the wireless LAN station model, there is only a source, then we have the wireless LAN interface, and then we have the standard wireless LAN MAC model inside this process model. Now, the source can be programmed or configured, and I'll show you how you would do it today in this tutorial to generate a certain bit stream and associate a certain type of service to the packets generated by the source, and then they are straight away forwarded to the MAC layer. Now, if we click on wireless LAN station, workstation, sorry, this is quite different than the wireless LAN station. Here you would find almost all of the layers, all the 7 layers of the OSI, right from the application. Then you have the transport layer. You've got the process model to actually manage the managed routing protocols. You have the UDP. You have got the mobile IP module. Then you've got the IP, ARP, and WLAN. So it gives you an option of if your research or your configuration does not involve something at the transport layer, or it has nothing to do or demonstrate the mobile IP functionality, or you're not using a particular routing protocol, and or in other words, I would say that your testing and experimentation is only concerned about the MAC layer performance. So for performance enhancements and optimization, usually you would not be using this model. Well, on the other hand, this is quite simple. Your simulation would run quite fast, and you would go for this one. So in this tutorial, our aim is to configure two of such stations. One of these stations, I'll just copy, Control C, and then Control V. I'll paste another station which is similar to this one. In this tutorial, my aim is to configure this station, which is mobile node 0, to send traffic to mobile node 1. The traffic would be a constant bit rate traffic, CBR, of 1 megabits per second. So let's go right click on it, select the edit the attributes. Now you can change the model family, which is wireless LAN station. You can change the name of this one. You can rename it to whatever you want. You can assign a trajectory. I'll show you in the next tutorials how to assign a trajectory. Then you can set the destination address. In this case, I would assign a MAC address of 1 to this one and a MAC address of 2 to this guy. And I want this station, which is mobile node 0, to send traffic to the station having a MAC address of 2. So I'll specify the destination address 2 in this case. If I leave it random, I've got two other options. I can leave it random, then OpNet would randomly select a destination, and the traffic generated by this station would be sent to that station, or I can leave it to broadcast. Now I'll come to the second option, which is traffic generation parameters. In here I have got the start time in seconds. By default it is set to never. What I'll do is I'll set it to a constant 10, which essentially means that this station is programmed to start generating traffic after 10 seconds. You can select any other distribution and then specify the relevant parameters, and it can randomly select a time interval for starting the generation of packets. The other option that we have here is the on state time and off state time. You should view it as two on and off buttons. So essentially, it gives you the option to turn your packet generation on for a particular amount of time here by specifying it. In here, I would like this station to send constantly for 10 minutes, which makes it 600 seconds. And I don't want to turn itself off, so I'd select constant duration of 0 seconds. Now, the next option is packet generation arguments. What size of packets I want to be generated by this station. As I mentioned before, I am interested to generate a bit stream of 1 megabits per second. Now, I would specify a packet size of constant 512, but if you look here, it says bytes. So I've specified a constant packet size of 512 bytes. Now, the next option that I have here, which is before the packet size, is the interarrival time. This means that what should be the duration or the space in terms of time between two packets generated by this station. Now my final goal is to generate a constant bitrate traffic of 1024000 megabits. Now to get the interval time, the easier step to do is to open your calculator. Now 512 bytes are equal to 4096 bits. Now each of my packets is of this size. The My final goal is to achieve this much bits per second divided by 4096, which is the size of the packet. So I would get the total number of packets which I have to have in order to have 1024 megabits per second. Now, this is my total number of packets which I need to have in 1 second, and the interval time would be 1 divided by total number of packets. So 1 divided by 250 would give me 0.004, which is the interval time for in this case. So I'll select constant again and put 0.004. I would select no segmentation, stop time is set to never. Now the other option that I have here is traffic type of service. The type of service is, you can specify it here, and the generated packets would be tagged with this with one of these arguments, one of these parameters. And in the MAC layer, in the IEEE 822.11e, the MAC layer supports 4 different access category queues. So one of the one is for voice, the other is for video, the third one is for best effort, and the fourth one is for background traffic. The voice has the highest priority, then followed by the video, and then best effort and background. So if you want to prioritize your traffic or the packet generated by this node to be prioritized over other traffic generated by other applications at the MAC layer of the source station or at the intermediate stations, you can specify some of the type of service parameters, and then based on the type of service parameters, the MAC layer would prioritize it. Now we have another option of wireless LAN. Here I would assign it a MAC address of 1. So this is my first station, which is the source station. It has a MAC address of 1. I would not touch the wireless LAN parameters. I would not change anything here. You can just have a look of all of these, and I come to these parameters and explain each one of them in the later tutorials. But in this case, the wireless LAN MAC is only operating in the DCF mode, which is the mandatory mode of operation, and I'm not using any of these optional modes, which is the PCF point coordination function and the HCF hybrid coordination function, and all of these are, in this case, they are disabled. So this, its MAC address is 1. I'll come to this one, edit attributes, straight away go to the wireless LAN MAC address, set it to 2. So this station's MAC address is 2, and this station is now configured to set whatever packets it would generate to a station having a MAC address of 2. So now everything is ready. All we have to do is to select some statistics of our own interest and run the simulation. I'll right click on it, choose the individual statistics, come to wireless LAN. I would just select this statistic, which is load in, in terms of bits per second. You can always see a description of each one of these statistics by hitting pressing this button. So we have selected a load statistic. The next option is to run the simulation. You can either select it from the menu, or you can straight away come to this button. Here I am interested to run the simulation only for 10 minutes, and I wouldn't change any of these, and I'll apply the setting and run the simulation. While the simulation is running, I'll pause the video. Okay guys, the simulation has completed. Now let's go and see the results. You can select it from here, view results, which is mobile node 0 in the wireless LAN, and here is my load statistic that we have recorded. You can always hit the or see the complete in a different window. You can change the way you want to display the statistics. You can delete it, and these are the different options that you have while you are simulating a network. So I think that's all for this tutorial. I'll see you in the next tutorial. Thanks for watching. Bye.